It's okay, what's up? In this class 9. Hey guys, it's Miss Hardy recording for Biomedical Technology 1, 4th period on September 24th. Clicking on our daily agenda today, we have your discussion post, of course, which I think is just asking you how you feel with this information. If you haven't logged into a Zoom yet, I made it pretty clear that this particular chapter is like 4 mini chapters, and so we're finishing up this first mini chapter before we move along. The rest of them won't take quite as long. This is the biggest chunk. But that's what it means when I say finishing up transgenic organisms and GMO. One clear distinction I want you guys to make really quick, because I don't know that it was made very clear. When we talk about transgenic organisms and genetically modified organisms, we are talking about transgenic organisms being a type of genetically modified organisms. We can genetically modify an organism's DNA and not necessarily put in a transgene and make it a transgenic organism. If you were to implant DNA from one organism to another, it's still a genetically modified organism, but it's just a special type called a transgenic organism. Does that make sense to everybody? So just look at GMO as your umbrella, and then under your umbrella is transgenic organism as one of them. And then if I were to genetically alter a strand of corn to make it where the corn repels mosquitoes, then that would be considered just genetically modified organisms. So the transgenic part, mixing genes from organisms, makes it that special kind. Okay, so what we're going to do is go over the quiz from yesterday, and then I'm going to explain to you your project that's due tomorrow. Okay, so we'll kind of come back to this agenda once I go over your quiz from yesterday. So we're going to click here on modules, and then I'm sorry, my computer's running a little slow this morning, guys. Then we're going to go here under Unit 3, Quiz 1, GMO. A little side note, guys, if you're making up work for my class, which I have completely kind of opened it up to do so during your 6 weeks, as long as it's obviously within reason, you can always access my documents online. You just won't be able to submit them on Canvas. And the reason that I do that is I don't always get notifications about submissions on Canvas. So if you do something that's considered makeup work, like today, if so-and-so does a makeup assignment today, I want it to come to my email so I can go in and manually change your grade right then and there. That keeps me on my toes and putting your grades in as soon as I can and as quickly as I can versus depending on Canvas to do that. Okay, so GMO and transgenic organisms quiz. So what is selective breeding? Okay, so selective breeding is basically picking two parents for certain characteristics and breeding them together to continue that selective characteristic that you've chosen. So I think one of the examples we use is if we wanted to have more lean beef and we had a certain genetically matched cow, like a stud or a steer that we knew created leaner beef cuts, then we could mix that one with a mature female of the same breed, and we could make that more genetically desirable breed of cow. Okay, now granted, I am not a cow farmer, cow raiser, breeder, so excuse my horrible descriptive terms. Okay, what is a transgene? Okay, what's a transgene? Absolutely, a gene that we remove from organism A and put it into organism B to create our product. I'm going to start referring to it as organism A and B because that's going to help you figure out your project coming up. List 3 potential benefits of transgenic organisms. If you didn't figure this out already, guys, this quiz came straight from one of the documents you've already created, literally already done it. It came straight from this document here, 3.02 transgenic organisms and genetically modified organisms. So it came straight from this, okay? So if you didn't use this, I love to throw these little quizzes in there to see if you use your resources. Every answer to this quiz came right from this document, okay? So list 3 potential benefits of transgenic organisms. It can be a model for human disease because we know animals are the best surrogate. It can improve the health and quality of livestock, okay? So obviously we want our livestock to be healthy and live a prosperous lifestyle as far as growing well and not being too affected by diseases, viruses, bacteria, because they are our food product. Producing pharmaceuticals, so medication, a source of organs for humans, because we know we xenograft from what animal most often? What animal do we take xenografts from most often? Pigs, you got it, perfect. Okay, and then a model for gene therapy in humans, because we're starting to manipulate genes within animals and livestock. So what is that going to be if we were to simulate that for human population? And then for sickle cell anemia and being able to replace those sickle cell blood cells. Genetic modification of blank genes outside the normal blank process. Okay, straight from the thing, I'm going to read it to you. Okay, genetic modification is the process of manipulating genes outside of the normal reproductive process. Okay, that's exactly what it was. And if you use another word that was not manipulating, I still took it. Yes, ma'am. Yep, if you use like making, creating, whatever, I still took it. The first transgenic organism was bacteria. You got it. And now we use bacteria in cheese, and we use it in yeast and all of those things. Biomedical researchers must go through an approval process to blank a transgenic animal by applying for a blank at the blank. Again, word for word, straight from your note guide. Biomedical researchers must go through an approval process to create a transgenic animal by applying for a patent at the U.S. Patent and Trademark Office. So to hit this really quickly, biomedical researchers, when we are creating a transgenic animal, are we creating something new? Are we? Yeah, we absolutely are, because we are making the first cow to have green hooves so that they are able to photosynthesize or whatever you want to do. Do what? Huh? It's still a cow, absolutely, but this cow is special because it has the genes that make its hooves green. So technically, it's considered a new breed of cow because we manipulated it. And let's say for some reason we start making money on these green cows. Well, if we want to keep that as our intellectual property, we have to patent it. Okay, a patent means that you created something new. So whoever the person was who created this thing called a lanyard to hold your keys on has a patent on this. And every time one of these is sold, that person has made money. Can you sell your patent? Absolutely. But until you sell it, it's your intellectual property. So think about the people who were able to genetically modify corn so that it would not die off because of a particular virus. Are they going to make more money because their breed of corn is more resistant to viruses? Yes, they are. So the patent helps protect their property. And when we're creating transgenic animals, you want to protect your property, okay? And the place to do that is the U.S. Patent and Trademark Office. And this is usually on your test for me. I don't know about your final because I don't make that, but that's a really important part. Okay. Number 7, a blank graft is taken from a species outside of the original. A xenograft, perfect. So a xenograft is taken from a species outside of the original. If I take it from myself, it's a homograft, okay? A homograft, I'm taking it from self, okay? And number 8, and I think guys in a previous recording, I may have said that one wrong, so I'm just clarifying right there. Xenograft is from a different species. Homograft is from the same type of species. So if I were to get a skin graft from Mr. Harris, okay? Number 8, blank is the technique of injecting DNA into animal cells. I took that word for word from this back page. Microinjection is a technique of injecting DNA, deoxyribonucleic acid, into animal cells. And so that's when we saw that really small embryo cell and we saw that needle puncture through to inject that DNA material. Okay, any questions on our quiz? Okay, perfect. So what I'm going to do is come back over here, go home, click on modules. And so now we have another project, okay? We have another project. Remember, projects get their own module, so to find it, you have to go here. This project is on transgenic animals. Now, in the past, this was my kids' favorite project because they truly created a 3D model of their transgenic animal. Unfortunately, we can't take any hands-on products from students, okay? So what we're going to do is I had to adapt this project so that you still learned and understood what transgenic animals are, but I had to give it and make it something that could be more virtual based. So here we go. Create your own transgenic organisms. For this project, you will create your own genetically modified organisms by implanting a gene from one animal into another for a specific reason to create a transgenic organism. Remember, we have GMO as the umbrella, and under GMO, we have anything that we modify genetically, and then we have transgenic organisms, or we take genes from different pieces and parts and put them all together. So for this project, you will create 4 genetically modified organisms. You must create genetically modified organisms that will benefit science. I'm going to explain that to you, but you have to detail at least 5 things for each organism. Organism A, so your first thing that you're taking your transgene from. Organism B, where it's going. You have to detail what the transgene is, and then you have to tell me what the final product would be. For number 5, in each organism, you have to list what the scientific benefit is. So I'm going to go through the example that I gave you. Now, again, it doesn't have to be corn. You see where my mind is? It doesn't have to be animals. You can do bacteria. You can use plants. You can mix plants and animals. Again, it has to be realistic within reason, but of course, we're probably not going to mix a king cobra with a Labrador retriever. But for this, for example, my organism A was a king cobra snake. My organism B was a Labrador retriever dog. My organism C was the fact that the king cobra is not able to carry or transmit the rabies virus. Okay, so snakes do not carry or transmit the rabies virus. That took a little bit of research on my part. Okay, so that's where the grade it's getting, this counts as more points than the first 2 because it takes research to know. I literally sat here and I Googled what animals do not carry the rabies virus. Okay, and this came up, guys, because I just had to take my dog to the vet and get his rabies shot, and I was like, oh my gosh, every 3 years we do this, and it's so expensive. How could we not have to do this? Okay, so number 4, my final product is a Labrador retriever that is unable to carry or transmit the virus to humans. Okay, so does everybody follow where I'm at? I had my snake. I knew that snakes didn't carry rabies. I had my dog. I knew that it did. Okay, what I did is I took the gene that makes it where a snake cannot carry rabies, took it out, and put it into my dog. So that's organism A, organism B, and the transgene. My final product is a beautiful Labrador retriever that cannot carry rabies. Absolutely, but you have to be able, so we had a student ask, can I make a snake that can carry rabies? Absolutely. But the 5th and final biggest piece of this puzzle, guys, it's worth 10 points, is what is the scientific benefit of the organism that you create? So the scientific benefit of a dog that cannot carry rabies is that it includes decreased transmission rates of rabies from canine to humans, decreased production cost of vaccines due to the decreased need for vaccinations in canines because they no longer carry and or transmit the virus. So that's a scientific benefit. And we know that the goal of biomedical technology is to utilize science to increase human function. Increase, well, it's to increase to benefit us, okay? So that's what we're doing. Does everybody understand numbers 1 through 5? So what I've done is I've given you 2 days to work on this assignment. By the end of the day today, you should have at least 1 done to keep you on track. You could potentially have all 4 of them done, but keep in mind, this is a project grade and you typically only have 1 to 2 per 6 weeks. This will be your first grade in your new 6 weeks. So you want to make sure this is a good one, okay? Because we're starting out strong. Some things to remember is that your scenarios for this project must be beneficial to science. So yeah, I think it would be awesome to have a bright purple dog, but what's the reason we would have a bright purple dog? Okay. And guys, we can make anything beneficial to science, such as if we were to have a bright purple dog, then society would be able to very quickly recognize those who are utilizing animals for seeing eye dogs. So be creative with this. This is your opportunity to think outside the box. while still benefiting science. They also must not be true. So the example that I gave is reptiles are not susceptible to the rabies virus. So the scenario above makes sense. I will be reading each one of your scenarios, so it has to make sense, okay? And then again, you do not have to use animals. Just remember, all organisms are fair game. Plants, animals, bacteria, etc. Be creative. And then I skipped one. You must detail your organisms, transgene information, and present your information in a neat and detailed document. If you want to number yours like this, 1 through 5, you can. And then, of course, you can label this just like I'm doing here. King cobra snake crossed with a Labrador retriever. Okay, and that tells me what your organism is. And if you want to make them a cool color, that's fine with me. I'm going to make this one pink because that just was easy to find. Okay, you can absolutely give it a name, whatever you want, but it needs to be submitted to me by tomorrow night at 11:59 p.m. This is your first assignment for your next 6 weeks. So again, I'd say let's start out strong and do your best on this. You have the rest of class today to work on this and ask me clarifying questions. When you submit this, just submit it either as a Google Doc or a file upload or a text box entry. And probably what you'll spend most of your time on is figuring out, I like to start with my number 2 organism. So what am I crossing? And then what do I want them to be able to do? And then I find an animal that fits that. Some key tips and tricks for those of you who watch the Zoom: look at your endangered species, right? If we know that elephants are endangered because of their tusks, how can we cross an animal with elephants so their tusks are no longer valuable? Does that make sense? So I always looked at my endangered species. This one was, again, because I don't want to have to pay for a rabies vaccine in my dog, okay? So does anybody have any questions, comments, concerns? All right, so if you have questions, you know that I'm here. I'm going to stop recording at this